I grew up in Los Angeles, California, in the 80s and 90s. My mom worked for the Los Angeles Department of Water and Power, and as her career progressed, she ended up in the water conservation office, where a lot of what she was doing was trying to figure out ways to develop and implement water conservation programs. Being exposed to that as a child, and we would have, there would be kind of drought conditions, and we would have to, do things, stop watering the lawns, and that's like, I grew up with this ethos around water and the importance of water. So that when it was time for me to go to college, I was interested in water, and I started in civil engineering. And like many people that started in engineering, I kind of got my feet wet and was like, well, I'm not sure this is for me. And that landed me in environmental geology. And that's where the spark lit. So my research program is in geologic carbon sequestration, and the idea with geologic carbon sequestration is that it is one of numerous technologies that we can use to try to, mitigate CO2 release into the atmosphere. And we know that, after decades of research, CO2 accumulations in the atmosphere are causing deleterious problems. Things like, storm intensities are increasing, hurricane seasons are getting more severe, fire intensity is increasing. Areas that were once, sort of fertile are becoming more dry. As we're, pumping water out of aquifers along coasts, land levels are falling, sea levels rising. So there's lots of different ways that we want to try to mitigate both the source of, some of these, issues, as well as, technologies that can, kind of help, right? And so what I study is pumping fluids underground. So with geologic carbon sequestration, the idea is, you start with a point source CO2 emitter, something like a power plant. You burn coal or natural gas to produce, electricity. That releases CO2 into the atmosphere. Cement manufacturing is another one, right? So in cement manufacturing, you're going to take limestone, heat it, get it very hot, create what's called clinker, and that releases CO2 to the atmosphere. Ethanol production releases CO2 to the atmosphere. Steel manufacturing, all of these industrial processes that are really important for our, economic development, for our quality of life. These are things that produce CO2 that release it to the atmosphere. And so carbon capture and storage is a technology that pulls the CO2 from the kind of industrial exhaust, takes the CO2 out of the purified stream. And so once you have that CO2, what can you do with it, right? We can reuse it. There are some processes where you can use it for things like decaffeinating coffee, for putting it into, carbonated beverages, food grade CO2. Greenhouses use CO2 to kind of help with plant growth. But we make a lot more than we could ever use. So one technology is to take that CO2 and pump it back into deep geologic formations. So, if our aquifers are several hundred feet deep, we're talking, many thousands of feet deep, miles underground. And so we study the rocks that, can potentially take that CO2, and where does it go? How secure is it? What is the time scale? What happens to that CO2 when it's underground? So this is important because if we want to continue economic growth, we need these industrial processes are kind of the engines of that growth. And we need to do it in a manner that is reducing the amount of CO2 that's going into the atmosphere. And this is important, kind of worldwide. I think my mom is proud of me. I think she's very proud of me. I think she sees her influence, bringing me up in that environment of, sort of an environmental ethos that, water conservation matters. And so what matters never changes, but we add to things that matter. I never would have thought that I'd be studying, CO2 storage underground, but it's related to the water ethos that I grew up with. If carbon storage turns out to be a game-changing technology, and that it does have a monumental impact, it will be a whole network of scientists that have been studying this for decades, right? So we talk about standing on the shoulders of giants, right? There have been people that have been, kind of working on this technology and demonstrating it and trying to prove that it would work and explaining all the different, sort of economics around it. I mean, if it works, I will have been a part of something, I think, pretty special.